2006 Grade 9 Friar Math Contest. Samantha receives the following marks out of 107 of her 8 courses. Determine her average mark in these 7 courses. So you would just add up the numbers, 94, 93, plus 84, plus 81, plus 74, plus 83, plus 79. And then, of course, you would divide by the total number, which in this case is 7. And this is going to be 588 over 7, and that is 84. So that's the average. Part B. Before she finds out her actual French mark, Samantha calculates the highest possible average that she could obtain in all 8 courses. Determine this average. So in the first 7 courses, she got a total of 588. Now the French course, the highest she could possibly get is 100. So let's say she gets 100. And then the average would, of course, be calculated by dividing by 8 this time. And they're telling you to figure out what that average is, okay? So this is 688 over 8. And 688 divided by 8 is 86. And that's the highest possible. Part C. When Samantha actually finds out her French mark, it turns out that her average in all 8 courses is 85. What is her actual French mark? So that means that this 588 doesn't change, of course, and then we are trying to figure out that French grade, so I'll call it F, and then we're dividing by 8, but then they told me that that average is 85. So basically that's the setup of this question, and then you just solve for this. So 588 plus F is equal to 85 times 8, which I believe is 680, and therefore F would be equal to 92. And that completes number 1. Number 2. Dimitri has a collection of identical cubes. Each cube is labeled with integers 1 through 6, shown in the following net. This net can be folded to make a cube. He forms a pyramid by stacking layers of the cube on a table as shown, with the bottom layer being a 7 by 7 layer of cubes, square of cubes. Part A, determine the total number of cubes used to build a pyramid. Okay, so the bottom row looks like it's 7 by 7, right? They even tell you that. So that's 49 cubes. The row above it is a 5 by 5, and that is 25. The row above that is a 3 by 3 row or square, and that's 9. And then finally the 1 cube at the very top, I guess you can call it a 1 by 1, that's 1. And then we add up these guys, so that's what, 84? Yeah, 84. Part B. How many faces are visible after the pyramid is built and sitting on the table? Okay, so we got to do a little bit of counting here. So 1, 2, 3, 4, 5, 6, 7, and then there'll be 7 on that side, and then that's 14, and then 15, 16, 17, 18, 19, and then another 5 on this side, right? So that would bring me up to 24. Okay, but then I also have to count these sides, 1, 2, 3, 4, 5, 6, 7, and then there's going to be 7 on this side, and then 7 on the back side, and 7 on this side over here. So that's going to be 7 times 4. So this is 24 plus 28, which is 52. And we use the same sort of strategy on the next row. So this is let's look at the top. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there'll be 16. Then we have to count the sides, 1, 2, 3, 4, 5, and then of course there's going to be 4 of those, right? This, and then the back, and then the other side. So 16 plus 20, that's 36. And then we get to the next one, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. And then 1, 2, 3, and then there's going to be 4 of those. So this is going to be 8 plus 12, which is 20. And then finally, the very last one, all the sides are visible except the bottom, so that's going to be 5. So if you want to do it the way I was doing it, it'd be 1 plus 1 times 4, so 5. So that's just a systematic way of doing it. And if you add all these up, it's 113. I believe, yeah. Okay, last one. Explain in detail how he should position the cube so that if all of the visible numbers are added up, the total is as large as possible. And what is that total? Okay. Well, let's talk about this. Let's take it one step at a time. Let's first just talk about a corner. This guy right here. A corner will have only 3 sides visible, right? Yeah, because the other 3 sides will be not visible. So if we want to make it, if we want the numbers to be as large as possible, we'd put like a 6, a 5, and a 4 like that. So the 3 sides that are visible would have the 6, 5, and the 4. Okay, and then the sides, these guys, only 2 sides are visible. So we would want a 6 and a 5, right? Because you're choosing from this guy right here. Okay, so I guess that shouldn't be too hard. Let's do this one step at a time. Let's start with the bottom row. How many corners do we have? We have 4 corners, right? So 4 corners, and each corner will have a 6, a 5, and a 4. So that total is 15. And then we have all these sides. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So there's going to be 5, 5, 5, and 5. So 20 of those sides. And then each side would have a total of 11, 6 plus 5. So there you go. And this is going to be 60 plus 220. So that's 280. Okay. And then we just have to follow that same kind of principle. Now we get into this corner. Same thing, 4 corners. Each of them will have 15. And then the sides, 1, 2, 3. And then there's going to be 3, 3, 3. So 12 of those guys. And each of them, as previously, would have a total of 11. So that looks like 60 plus 132, so 192. And then we get to the next one. Again, 4 of those corners, each has a total of 15. And then we have 1, 2, 3, 4. Only 4 this time that are called sides. So that's going to be 60 plus 44, so 104. And then finally, the very top guy. Now, the very top guy is a little bit different of a conversation. All sides are visible except one side. So I guess I'll make that one side that's not visible the 1, and therefore all the other numbers would be visible. So the sum of the other numbers would be 15, 20. Yeah, so just one side, 1 times 20, I guess. So 20. And then to get the grand total, we would add up this 280, this 192, this 104, and this 20. And when you do, you get a grand total of 596. Three congruent isosceles triangles, DAO, AOB, and OBC have AD equal AO equal OB, and AB equal to DO equal OC. And these triangles are arranged to form a trapezoid ABCD. Point P is on the side AB, and OP is perpendicular to AB. All right, so what is the length of OP? So I guess we just have to figure out basic Pythagoras here. So OP squared plus PB squared is equal to OB squared. So OP is what we're trying to figure out. PB is, AB is equal to 12. So since P is perpendicular, it would cut that in half. So it would be 6 and 6 like that. So therefore PB is 6. So you have 6 squared. And OB, they've labeled it as 10. So 10 squared. So OP squared is going to be 100 minus 36. So OP looks to me like 64. And OP squared, and then OP is going to be 8. Yeah, that's it. What is the area of trapezoid ABCD? Okay, so the area of a trapezoid, if you have a trapezoid, let's say like that, and this is A and this is B, and the height is H, the area is calculated as A plus B divided by 2 multiplied by H. So in this case, ABCD, I guess that's the whole thing. So that area would be, A, I guess, would be that, which is 12. B is from here to here, which is 24, divided by 2, and multiplied by the height. Oh, the height is this one, which we just calculated actually, which is 8. Okay, so that's it. So 36 divided by 2 is 18, and 18 times 8 is what, 144? Yeah, 144. Okay, and then we get to the last one. Point X is on the midpoint of AD, and point Y is on the midpoint of BC, where X and Y are joined. The trapezoid is divided into two smaller trapezoids. What is the ratio of the area of the trapezoid ABYX to the trapezoid XYCD? Explain how you got your answer. Okay, so I guess we just use the same kind of formula, this one up here, but we have to know the dimensions. So let me just draw them separately. A, B, X, Y. And then, of course, the bigger one, which would be X, Y, D, and C. Okay. So they're saying that X is the midpoint of AD, right? So that means that from here to here is going to be the same as from here to here. So I guess from there to there is the same as from that line to the bottom. That's a pretty valid conclusion. So since the whole length was 8, then these lengths are 4. Okay, so that part is pretty easy. Now AB, we know that's 12. And then DC, we know that's 24. So I guess we just have to figure out XY, and then we should be done. Okay, XY, you can kind of look at it. I just did it with similar triangles. Like I just took this triangle right here, like that, and then compared it to the big one. So for example, from A to X would be 5, right? Because it's the midpoint. So A to X is 5, X to D is 5, and then D to O is 12. So let's just call this Z here, this point. So that basically means by similar triangles that XZ over 5 is the same as, well, let me just write it out in letters first. XZ over AX will be the same as DO over AD, right? Fundamental property of similar triangles. So XZ is what we're trying to figure out. AX we know is 5, DO is 12, and AD is 10. So this would give me that XZ is equal to 6, right? Yeah, 6. So therefore, this is also 6, and this is also 6. So we have 6, 6, 6. So X to Y would be 18. And that's pretty much all you needed to do to finish off this question. So now let's figure out the areas. This would be 12 plus 18 divided by 2 times 4. And that looks like 60. This one is 18 plus 24 divided by 2 times 4. And that is, let's see here, 42 times 2, 84. Okay, so the ratio, therefore, finally, would be 60 over 84, which is 5 over 7. Or you can write it as 5:7, whichever way. Either one is valid. How many of the positive integers from 1 to 100 inclusive do not contain the digit 7? Explain how you got your answer. Okay. Well, there's a couple ways of doing this. The first way is sort of doing it manually, where you have the total, do contain 7, and then don't contain 7. And since it's only 1 to 100, I'll do it manually first, and then I'll show you a shortcut. Because once the numbers get bigger, it's going to be a lot more time consuming to do it manually. But this is really short. So, all right, so 1 to 9, that range, there's how many numbers? There's 9 numbers. And how many do contain 7? Only 1, and that would be just the 7. Don't contain 7 would be the other guys. So 9 minus 1, which is 8. And those, of course, are numbers 1, 2, 3, 4, 5, 6, 8, 9. Okay, the next range is 10 to 99. And then the final is 100. Let's just do the 100 first. How many numbers are there? Well, only one. How many contain 7? 0. And don't contain 7, 1. Okay, great. Now, between 10 and 99, how many numbers are there? 90. How many contain 7? Okay, so we're going to have to do some counting here. 17, 18, 19. Oops, what am I doing? 17, 27, 37, 47, 57, 67, 77, 87, and 97. Those 9, right? And then all the 70s, 70 to 79, which would be 10 numbers. So these 10 and these 9 is 19. But here's the thing. The 77 is counted twice. It's counted in that group and it's counted in that group. So you got to subtract that. And that's the trickiest part about this question. So of the 19, you have to subtract 1 because it was a double count. So it's actually 18. And therefore 90 minus those 18, which is 72, do not contain 7. So the total would be the total of these three numbers, which is 81. Okay. Now, there's a quicker way, a much quicker way, is if you have any number between 1 and 100, it could be written like that, right? Where this digit is anything from a 0 to 9 except a 7, because you don't want a 7. Now, 0 to 9 is 10 digits, but we don't want the 7, so we only have 9 digits remaining, so we have 9 choices for that one. In a very similar way, that number also can be anything from 0 to 9 except a 7. So that also is 9 choices. 9 choices times 9 choices is 81, and that's how you got that 81. So either way, you get the same answer, but this way is, of course, this way is much shorter. Now, before I jump to part B, I would like to add up these guys. 17 plus 27 plus 37 all the way up to 97, then 70 to 79. Now you might say, well, why? What's the point? Well, it'll be useful later on. That sum is 1188. And then later on, I think it's part C, we have to figure out the sum. So as you can see here, so then we'll be able to utilize this number. Okay, now we jump to part B. How many of the positive integers from 1 to 2,000 inclusive do not contain the digit 7? Okay, so I'm definitely going to use this system right here. I'm not going to use this system because it would be too time consuming. And I think I can do it without too much space. So here we go. Now they want from 1 to 2,000, right? Okay. From 1 to 2,000. Okay, well, there's 2,000 numbers there, and the number 2,000 does not contain a 7. So I can really just say from 1 to 1999, because if I interchange 0 for 2,000, the answer to this question will be the same, because 2,000 doesn't contain a 7, and 0 doesn't contain a 7. It's just if I make the range 0 to 1999, it just makes the question easier. The answer will be the same. Okay, so every number in that range can be written as, a 4-digit number. I mean, the digits could be zeros, but it could be written like that. And let's see what are our choices. For the first guy here, that can be either a 0 or a 1. Any number in this range here. So I've got 2 choices. The second guy can be any number, any digit from 0 to 9, except 7. Right? Because you don't want 7. So that gives me 9 choices. Very similarly, there's 9 choices here, and similarly, 9 choices here. So you multiply them all, and when you do, you get 1458. And that is the correct answer. So as you can see, you can get the answer very quickly with this system. If you did it this way, it would be much more time consuming. Okay, now we get to the big part here, the big one. Determine the sum of all of the positive integers from 1 to 2006 inclusive that do not contain the digit 7. Explain how you got your answer. Okay, so here we go. So this is a nice table here. Let's take this table one step at a time. Let's not get too excited about the entire table. Now I have to explain some of this stuff to you. Here's the table, and off we go. I've got to explain it all. Okay, so let's start. From the range right here, 1 to 100, this one, there are 81 numbers that do not contain the 7, right? And that was something that we had calculated actually previously. I think we calculated that in part A of this question. Now we have to add those up. Okay, now you guys know that all the numbers, all the consecutive numbers up until n are added with a formula. Now if you're in grade 9, you may not know that, but let's just put that formula. It's n times n plus 1 over 2. So all the numbers from 1 to 100 would be 1 plus 2 plus 3 dot 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 all the way to 100. So that would be 100 times 101 divided by 2. Correct? Okay. So that basically is, well, whatever that number is. I think it's 50-50. And then, if you remember, I had added up all the numbers that contain 7, and that sum, if you recall, was 1188. So when you subtract 50-50 from 1188, you get 3862. And that's how they got that 3862 there. You got it? Okay, so let's move forward. Now we get to the next range. How about 100 to 200? This time we have numbers like 101, 102, 103, all the way down to 199 and 200, right? Well, these numbers all begin with the number 1, well, except the last one has a 2. And they're sort of like 100 plus 1, 100 plus 2, 100 plus 3, right? Dot, 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 100 plus 199, 100 plus 100, I guess. And these guys here are pretty much the same. Sorry, this should have been just 99 right here. That should have been just 99, sorry. So those numbers are essentially just the same as the first range, 1 to 100. So therefore, their sum is going to be very similar. The sum would be the same, which is 3862, right? This sum would be 3862, right? Without the 7s, and without any of the numbers that contain a 7. But then you have to add up all these hundreds. Well, how many hundreds are there? Well, remember, there was 81 numbers that do not contain a 7. So 81 of these hundreds. So 81 times 100. So that's how we got that calculation. You got it? And then similarly, for 201 to 300, it's the same thing. So this time we have 201, 202, 203, dot, 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 all the way down to 299 and 300. And these numbers are similar. It's like 200 plus 1, 200 plus 2, 200 plus 3, and then all the way down to 200 plus 99, 200 plus 100. Well, all these guys add up to 3862. Remember, because we're only counting the numbers that do not have a 7, just like up here. And then these guys, this whole thing would be, well, there's 81 of them, and each of them is 200. So that's how we get that one. So that's basically how you would proceed with this question. And then similarly, the next one, and the next one. But then we get to a point where it's not that simple anymore. That one right there. Well, this one here, let me just look at this one. This one we pretty much know. But then this one, you got to be careful. Because from that, in that range, which is this range right here, everything's fine, but that very last number, 700, that has to be subtracted because remember, we can't include any number that has a 7 in it. The next range, every number in that range has a 7, except the 800. So therefore, the only number we need to add is that 800. And then it kind of proceeds in a very similar way for the next several, right, up until this point. But then when we get to this range, we have to be careful because that 1700 has a 7 in it, so we can't use that. So that's why we have to subtract it. And in this one, in that range, every number has a 7 except the very last number, which is 1800. So the 18 number is the only number we're going to add. And then it just continues in a very similar way for that one and that one. And these numbers, you just add them manually. And then what you do is you add this whole thing up, however you want to do it. And when you do, the grand total will be 1,426,337. So 1,426,337. So that is the answer to a relatively challenging question for grade 9.